session we are going to discuss about the Fourier series of even and odd functions. First we see the definition of even function. A function f of x is said to be even if f of minus x equal to f of x for all x. A function f of x is said to be odd if f of minus x equal to minus f of x. Examples to even function are x square, x power 4, cos x. All these are even functions. And to odd function examples are x, x cube, sin x are odd functions. Here we see some important points regarding even and odd functions. Product of two even functions, that is even function into even function, becomes an even function. Product of two even functions is an even function, and product of two odd functions is an even function. Even into odd function, even function into odd function is an odd function. We should remember these three. And after that, if the function under the integral is even, the function under the integral is an even function, in that situation integral minus a to a becomes 2 into integral 0 to a f of x dx. Able to write down the integral minus a to a f of x dx as 2 into integral 0 to a f of x dx if the function under the integral is even. If the function under the integral is odd, in that situation integral minus a to a f of x dx, integral value becomes 0. If the function under the integral is odd function, in that situation integral value becomes 0. Now we see Fourier series of an even function. Fourier series of an even function. Let f of x be an even function defined in the interval minus pi less than or equal to x less than or equal to pi. That is, let f of x is an even function defined in the interval minus pi to pi. In that situation, what about the three Fourier coefficients a0, an and bn? Actually, in the last sessions we did Fourier series of function f of x defined in the interval 0, 2 pi as well as minus pi to pi. Whatever the interval, Fourier series to the function f of x we have taken as Fourier series of f of x is f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx. This is Fourier series expansion to the function f of x. Here a0, an and bn are Fourier coefficients we determined in the required interval. So here also we have the three Fourier coefficients, but we see what happens in particular if f of x is an even function. F of x is even function defined in the interval minus pi to pi. What about the Fourier coefficients? So the first Fourier coefficient a0 equal to 1 by pi integral minus pi to pi f of x dx. Here f of x is even function. So if the function under the integral is even, we are able to write down minus a to a as 2 into 0 to a. Accordingly, minus pi to pi can be written as 2 into integral 0 to pi f of x dx. This is a naught value. Now an equal to 1 by pi integral minus pi to pi f of x cos nx dx. Here f of x is even, that is clearly mentioned. Cos is also even function. Product of two even functions is even function. So the function under the integral is even. Able to write down minus pi to pi as 2 into integral 0 to pi f of x cos nx dx. This is an. A naught equal to 2 by pi 0 to pi f of x dx. An equal to 2 by pi integral 0 to pi f of x cos nx dx. Now bn equal to 1 by pi integral minus pi to pi f of x sin nx dx. Here the function under the integral is even, sin is odd function, product of even and odd function is an odd function. So the whole function becomes odd. So as the function under the integral is odd, the integral value becomes 0. That means Fourier coefficient bn becomes 0. So what you understand is, actually Fourier series of f of x contains 3 Fourier coefficients, but if f of x is an even function defined in the interval minus pi to pi, in that situation directly we will get bn 0. That means for even function defined in the interval minus pi to pi, its Fourier series contains only a0 and an Fourier coefficient. Therefore, Fourier series of an even function defined in the interval minus pi to pi is f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. This is Fourier series of an even function. Means Fourier series of an even function contains only the cosine terms. Fourier series of an even function contains a0 and an terms. Now we see Fourier series of an odd function. Fourier series of an odd function. If f of x is an odd function defined in the interval minus pi less than or equal to x less than or equal to pi. If f of x is an odd function defined in the interval minus pi to pi, in that situation we see the Fourier coefficients. Actually a0 equal to formula 1 by pi integral minus pi to pi f of x dx. Here the function under the integral is odd. So if the function under the integral is odd, integral minus a to a, here particular minus pi to pi f of x dx becomes 0. That means a0 Fourier coefficient vanish. An equal to 1 by pi integral minus pi to pi f of x cos nx dx. Here the function under the integral is odd, cos is even, the product of odd and even functions is an odd function. So as the function under the integral is odd function, we have the value 0. Now the bn Fourier coefficient equal to 1 by pi integral minus pi to pi f of x sin nx dx. Here the function under the integral is odd and sine is odd function. Product of two odd functions again an even function. Product of two odd functions is an even function. As the whole function under the integral is even, we are able to write down the limits minus pi to pi as 2 into integral 0 to pi f of x sin nx dx. This is Bn Fourier coefficient. So actually Fourier series of function contains a0, an and bn Fourier coefficients, but here particular for odd function defined in this interval, we have a0 and an vanishes. It contains only bn Fourier coefficient. Therefore, Fourier series of odd function defined in the interval minus pi comma pi given by f of x equal to sigma n equal to 1 to infinity bn sin nx. Therefore, Fourier series of odd function contains only sine terms. Fourier series of an even function contains cosine terms. In other words, Fourier series of an even function contains only a0 and an terms, and Fourier series of an odd function contains only bn terms.